Hello everyone. Let's get back to the worksheet problems. Problem number 2 has already been completed for you. Please make sure to go through that. I'm going to get started with problem number 3 by drawing a vertical line to demarcate heap space from stack space. Heap is going to be on the right hand side and stack is going to be on the left hand side. I'll be going through every line of code. Line number 1 is creating a list object instance which is storing two integer object instances as items. Then we are adding a reference to the list object instance into the variable nums1. I'll have to draw the list object instance box as part of my heap space. If I want to be accurate with my representation, I'll draw an arrow from the subbox 1 to the integer object instance 2, and similarly another arrow to the integer object instance 2 from subbox 2. I'll have to draw the nums1 variable box as part of my stack space, and I'm going to include an arrow from nums1 to the list object instance to indicate that nums1 is storing reference. Line number 2 is saying nums2 equal to nums1. Recall that creates a reference copy. So you're going to include an arrow from nums2 box to the exact same list object instance that we just created. Line number 3 is invoking pop method on nums2 by passing integer 1 as argument. We are capturing the return value into a variable called x. Let's first track the reference arrow from nums2 variable that's going to take us to this particular list object instance. I'm going to write down the index positions. The positive index positions are going to be 0 and 1. The negative ones are going to be -1 and -2. Recall that pop method enables you to remove an item at the index position provided by the argument and also return that particular item. The item at index position 1 is going to be the integer object instance 2. So we are going to eliminate that particular item from the list object instance. What are we doing with the return value? We are storing that within a variable called x. So I'm going to draw the x variable box as part of my stack, and I'm going to include an arrow from that to the integer object instance 2 here. I'll move on to problem number 4. I'll be using the same vertical line demarcation for problems 4 through 6. Line number 1 is creating the exact same list object instance. I'm going to directly write down 1 and 2 within the list object instance box here. Let me add a reference from the variable x box to this particular list object instance. Line number 2 here is creating a brand new list object instance which is storing the value as 3, and we are including a reference to that within the variable box y here. Line number 3 is using the concatenation operator to concatenate x and y, and it is storing the result into a variable z. Recall that the concatenation operator creates a brand new list object instance. So you're going to take all the items from the list object instance referenced by the variable x and include those, and you'll also take the items from the second list object instance which is being referenced by the variable y here. So you'll end up with a new list object instance which contains the values as 1, 2 and 3 here. I'm going to add an arrow from the z variable box to this brand new list object instance that we just created. Let's go through line number 4. Line number 4 is calling the append method on the variable y to append the integer item 4 which is passed as an argument. Let's keep track of the arrow from variable y here. That's going to take us to this particular list object instance. We are going to add a new item 4 to that list object instance. Please note that this has no impact whatsoever on the other two list object instances because They are totally different objects. Let's go through problem number 5. Problem number 5 is creating a dictionary object instance. So I'm going to use a vertical representation to indicate dictionary. My key here is going to be Alice first. So I'm going to write down the string Alice. The second key is going to be Bob, and I'll have to draw a box which keeps track of the values. Let me use an arrow representation here. Alice keys value box is going to include a reference to the integer object instance 30. Similarly, Bob's value box is going to include a reference to the integer object instance 25. Line number 2 here is creating a reference copy. Before I move on to line 2, I'll have to draw the people box and add an arrow from the people box to this particular dictionary object instance. Going back to line 2 is saying x equal to people. That will create a reference copy. X variable box is now going to include an arrow to the exact same dictionary object instance here. Line number 3 is using the lookup operation to extract the value corresponding to the key Bob, and we are storing that particular lookup value into the variable y. So let me create the variable y's box. What is going to be the reference stored inside the variable y's box? Let's keep track of the arrow from the people variable box here. That's going to get us to this particular dictionary object, and we are looking up the value corresponding to the key Bob, which is going to be this particular integer object instance 25 here. So you're going to add an arrow from y variable box to the integer object instance 25. Line number 4 here is updating the value corresponding to the Alice key. We are changing the value to integer object instance 31 here. So that's going to remove the previous reference within the Alice value box, and we are going to create a brand new reference which is going to point to the integer object instance 31 here. In line number 5, you're saying y equal to 26. This is going to only impact the reference within the variable y. You're going to remove that particular reference, and you're going to include a reference from the y variable box to the integer object instance 26. So I'm going to write down 26, and I'll be drawing an arrow from the y variable box to the new integer object instance 26 that we just created. Do not get confused as to whether this will impact the original dictionary object. It will not, because that is a totally different object by itself. You're not updating the reference which is stored within the Bob's value as part of the original dictionary object instance. Let's move on to problem number 6. Problem number 6 is slightly tricky. That's because we have to deal with frames. So far in problems 3 to 5, we've only been dealing with code within the global frame. So we did not draw the global frame specifically. Let's go through the lines of code within problem number 6 here. We are first defining a function f. After that, we are creating a list object instance which is storing 3 integer items of 1, 2 and 3. So I'm going to draw the list object instance within my heap space here. For simplicity, I'm going to write down the numbers 1, 2 and 3 directly within the box instead of using arrows. Then we are including a reference to this particular list object instance inside nums variable. So I'm going to draw the nums box here, which is going to have an arrow to the list object instance. If we want to be accurate, we'll have to draw the global frame around this particular nums variable box. So I'm going to go ahead and do that. So the global frame is going to include the nums variable box here. Let me write down global beside that particular frame. The next line of code is calling the append method on nums, and it's passing the return value of f of nums as argument. So let's first invoke the f function by passing nums as argument. Recall that that's going to create a brand new frame here, which is going to be for the f function call. Within the f function call frame, we are going to draw a variable box for the parameter variable items here. Recall that your items parameter variable here is going to reference whatever is being referenced by the argument, which is nums here. So you're going to include an arrow from items to the same list object instance. Let me write down the function name f beside the frame box here. So what are we doing within the function? We are first of all invoking the pop method to pop the item at index position 0. So if you track the items arrow here, that will take you to this particular list object instance. So I'm going to write down the positive index positions, which are going to be 0, 1 and 2 here. When we execute the pop method, that's going to delete the item 1 from that particular list. And what are we doing with the deleted item 1? We are returning that particular value as a return value from the function f calls frame here. If you want, you can keep track of the return value using an RV variable within the function call f frame. That's going to be similar to what Python tutor shows in terms of visualization. So if we were to include an RV variable, that would include an arrow to the integer object instance 1, because that's the value that we popped from the list object instance. What are we doing after the function call returns? Recall that that's going to get rid of all of the variables within the function f frame here. You're going to return the value which is going to be the integer object instance 1. We are taking that value and calling the append method on nums. Nums is going to take us to this particular list object instance here. Recall that append always inserts the new item at the end of the list object instance. So you're going to insert 1 at index position 2. That's going to be the updated index positions now, correct? So 2 is going to be at index position 0, 3 at 1 and 1 at 2. This is kind of a tricky problem. I would encourage all of you to go through all of these problems by typing them into Python tutor so that you can confirm your mental model version v2 diagrams for each of the problems. I'll wrap up this lecture video here.